Let us start with the next chapter, that is states of matter. Now, as you all know, there are three different states of matter or the physical forms of a substance. Those are solid, liquid, and gas. You all know this thing. Now, in these three different states of matter, the intermolecular forces are always there in between these, and depending on those intermolecular forces or the strength of intermolecular forces which exist between the molecules, the three states of matter exist. Wherever there are stronger intermolecular forces, it would be solid, or a somewhat less or the weaker one, it would appear in liquid form. And if the intermolecular forces are weaker or the rather weakest one, then the substance will appear in a gaseous phase. So these intermolecular forces are the attractive forces as well as the repulsive forces present between the neighboring molecules. And the attractive forces decreases with the increase in distance between the molecules. So these intermolecular forces are strong in solid and less strong in liquid and very strong or rather very weak, not very strong, very weak in gases. Now the three physical states of matter can be determined as per the strength of the intermolecular forces. So these are solid, liquid and gases. So there are five types of intermolecular forces. The first one, that is a dipole-dipole interaction. The first is dipole-dipole interaction. Second one, ion dipole interaction. Ion dipole interaction. And the third, that is dipole induced dipole interaction. Dipole induced dipole interaction. And the fourth one, hydrogen bonding. Hydrogen bonding. And the last one, that is van der Waals forces. Van der Waals forces, or these are also called as London dispersion forces. London dispersion forces. So out of this, the first two we'll study or discuss in this lecture: dipole-dipole interaction and ion dipole interaction. And the remaining three we'll discuss in the next lecture. So the first we'll go for dipole-dipole interaction. Dipole-dipole interaction. So this dipole-dipole interaction, this occurs between polar molecules, So this is very important word here, polar molecules. So the polar covalent molecules, I hope you know what is a covalent bond or covalent molecules, where there is a sharing of electrons. In case of covalent compound, there is a sharing of electron between the two atoms or polyatoms, and the bond is formed. Rather, the covalent bond is formed by sharing of electrons. Okay. Covalent molecules has two poles which is called as a dipole. Di means two. Is a dipole. And the partial positive charge and partial negative charge. Partial negative charge is developed and which results in the development of these two charges. It results in the polarization. Results in polarization and the possesses molecule possesses dipole moment. Okay, so before going to this dipole moment and polarization, let us see what are the polar molecules. So when you say a polar molecule means it should form a dipole or two poles should be there. This positive charge and the negative charge should be formed within the molecule and the two poles are formed. For example, like this, if you take a polar covalent molecule like HCl. Now this polarity of the molecule is totally dependent on the electronegativity of the atoms involved in the formation of a molecule. So electronegativity values will decide whether the molecule will be polar or a non-polar one. So if you look at this hydrogen chloride molecule, this chlorine is it is having a much more electronegativity value than hydrogen. It means that chlorine is more electronegative than hydrogen. So the bond which is existing between or a bond pair which is existing between hydrogen and chlorine, it is somewhat shifted towards chlorine due to its more electronegative nature. And there is a development of partial positive charge on hydrogen and partial negative charge on chlorine. And thus there is a formation of a dipole, and this formation of two poles or dipole gives the polar character to this molecule. Means development of dipole is very much important if you want or if you say that the molecule is a polar one. And this development of polarity is just due to the electronegativity values of the atoms involved in the formation of the molecule. So there should be the electronegativity difference between these two atoms should be there. If they are having the comparable electronegativity values, they won't be a polar one. Rather, they will impart a very little polar character. Means they will not be able to form a dipole easily. And if they don't form a dipole easily, they won't be called as a polar molecule. So polar molecules are those where there is a formation of a dipole, and this formation of a dipole is very much dependent on the electronegativity values. Means either of the two atoms, the one of them should be having more electronegative, and then this property of it to pull this electron pair towards itself will result in the formation of the dipole, and the molecule will be called as a polar one. Now this same thing can be applied to this also. Another example you can take water molecule. So this you can see this oxygen is a more electronegative than this hydrogen atom, and this presence of this oxygen here, it will create partial negative charge on oxygen, and there will be development of partial positive charge on this hydrogen, and this is a polar molecule. Okay, means this bond between oxygen and hydrogen, it is somewhat shifted towards this oxygen, and it gives or it induces or it produces a negative charge or partial negative charge in oxygen due to the more electronegative nature of this oxygen atom. Means the elements like nitrogen, oxygen, chlorine, bromine, and so on Means most of them they belong to the P block or the non-metals rather. So these non-metals they will have more electronegativity value, and such atoms, if they are involved in the bond formation, they will show or they will rather result in the formation of the more electronegativity, and it will form two poles in the molecule, that is a dipole, and each of formation of dipole will result in the polarity of the molecule. Now if I take an example like this methane CH4, this is a non-polar one, because this carbon electronegativity difference between carbon atom and the hydrogen atom is very less or very little. So the formation of this positive and negative charge, or rather formation of the dipole, is not that easy as it is in case of this water molecule or in case of hydrogen fluoride molecule, where there is a presence of chlorine and oxygen as a more electronegative atoms. So this is not so in case of the molecule like methane, or rather the alkanes. Most of them are non-polar in nature due to the very less difference between the electronegativity values of carbon and hydrogen. Another example you can say like this. This is chloroform, CH3Cl, chloroform. This is the semi-polar molecule. This is non-polar, this is semi-polar, and this is the polar one. Means polarity of the molecule, it depends on the atoms which are present in the molecule. So it says this chlorine is a more electronegative atom than all these hydrogen atoms. So the bond between these of this electron pair is somewhat shifted toward this chlorine, which produces partial negative charge, and it will give some partial positive character on this carbon atom. But there is not no such dipole is formed between this carbon and hydrogen. So only there is a dipole formation between this carbon and chlorine here, and that produces, or that gives a semi-polar character to this chloroform molecule. Now instead of this, if you take an example like this, CCl4 carbon tetrachloride, which is again a non-polar one. Though there is a presence of all the four chlorine atoms which are having more electronegative character or nature than the carbon atom, but this bond, and this bond, all the four bonds between this carbon, they are pulled towards this chlorine with the same intensity. Means if you appear that this is the ball, and this ball is, we tied it with the four different balls in the four direction, and if you are pulling this all the four balls with the same intensity or with the same force, or if we are doing this, so this ball which is at the center, it will remain as it is, it won't change its position. The same is happening with this carbon atom. So due to this same intensity of, or the same difference between the electronegativity values, it is hardly difficult for this CCl4, that is carbon tetrachloride molecule, to form the dipole. So the dipole formation in case of this CCl4 molecule is not there. Dipole is not formed. And since there is no dipole formation, that gives non-polar character or non-polar nature to this carbon tetrachloride molecule. So this is about the polarity concept. So this concept is also given in your textbook in chapter number 5. You can refer to chapter number 5 where this polarity concept is explained there. Now, I was talking, I tried to make the things simple about this polarity and non-polarity, or polar and non-polar character of the molecule. So we came across this word, that is a dipole moment. So what is this dipole moment, which is denoted by mu, dipole moment, that is mu. So this dipole moment is very much important when you talk about the polarity of the molecule. So if the molecule possesses dipole moment, it will show polar character. So mu is equal to Q into R, whereas this Q is nothing but the magnitude of charge, and R is nothing but the distance between centers of positive and negative charge. Positive and negative charge, which is formed due to the difference in the electronegativity values. Now this mu, it is a vector quantity. Mu is vector quantity. Mu is nothing but a dipole moment. Mu is what is this? This is dipole moment. It is a vector quantity and it is shown as arrow. Means this is shown this way with the arrow. This is the head and this is tail of the arrow. Here there is a positive charge, that is the dipole which is formed, and the partial negative charge is formed. So where this arrow is heading, always it heads towards the partial negative charge. So tail is the positive center. So you can see here tail is the positive center and head is also always a negative center. Okay, so this is the way polarity of the molecule can be expressed. If you can write this by taking example like this, HF, hydrogen fluoride molecule. So as you know, fluorine is the most electronegative element. These are the lone pairs on it. So this shows that when I put the arrow this way, it means that this is the negative center. There is a negative center on this fluorine and there is a positive center on hydrogen. So the cross arrow, this is the cross arrow. Okay, this is the cross arrow. Above this Lewis structure, it represents an electron density shift. So this arrow shows that the electron density is shifted from hydrogen towards fluorine. It means that. Okay, this is the Lewis structure. This is for the Lewis structure of hydrogen fluoride. So the polar molecules, they will always have permanent dipole moments. This is important. Permanent dipole moment. So the dipole moment which is developed due to the electronegativity difference between the hydrogen and fluorine or hydrogen and fluorine and so on. So that there is a development of permanent dipole moment. Now dipole moment is nothing but Q into R. So this is the magnitude of the charge which is developed, that is a partial positive and negative charge, and R is the distance between the centers of positive and negative charges which is developed due to the electronegativity differences between the atoms present in a molecule. Now when a polar molecule, it comes in contact or when it encounters, when polar molecule now I hope you know what is polar. I mean, there should be formation of a dipole, positive and negative charges. So when this polar molecule, it comes in contact or rather it encounters another polar molecule. So the positive end of one molecule If there are many molecules, they are coming in contact with one another. In such cases, the positive end of one molecule is attracted to the negative end of another polar molecule. End of another polar molecule. So this is quite obvious. If the molecule is like this is hydrogen chloride molecule H plus and Cl minus. If there is another hydrogen chloride molecule with a dipole, so there will be an attraction between the positive and negative charges. It means that. Okay. So these occurs only in solid or liquid state. So such three things are happening in solid or liquid state. Solid or liquid state. Means this dipole-dipole interaction, it is quite impressively occurring in case of dipole-dipole, in case of solid or liquid state of the molecule. Now this effect of dipole moment, it is also seen that the boiling point of the liquids, it is affected by the values of the dipole moment. Means if I quote an example like CH3, CH2, CH3 and alkane, its mu, that is a dipole moment, is 0.1, and boiling point for this alkane, it was found to be 231 Kelvin. Another example, if we take CH3O, CH3, dimethyl ether, its mu, that is a dipole moment, is 1.3, and its boiling point was found to be 248 Kelvin. Means there is a introduction of oxygen, which is an electronegative one, and see the great difference in the value of the dipole moment as an electronegative atom is introduced here, and there is increase in the boiling point also. Instead of this methyl chloride, the dipole moment is found to be 1.9, and its boiling point is higher, that is 249. Another methyl cyanide, its dipole moment is found to be 3.9, and its boiling point was found to be 355 Kelvin. Means that as the value for this it goes on increases, that increases the boiling point of the liquids also. So this is about the dipole-dipole interaction. Now let us talk about the second interaction, that is ion-dipole interaction. Ion-dipole interaction. Now these ion-dipole interactions, they occur between, as in the name itself, occur between ion and polar solvents. Remember, this is very important. Ion and polar solvents. Dipole-dipole interactions, they occur between polar molecules. And ion dipole interaction, they occur between ion and polar solvents. Now this ion may be cation or anion. Cation or anion. Okay. Now strength of this interaction, it depends on some factors. The first one, that is a size of strength, depends on size of an ion. Second, size and charge also. Size of an ion and charge of an ion also. Charge of an ion. Secondly, it depends on magnitude of dipole moment. I just explained what is dipole moment. Mu is equal to Q into R. Okay. And third is the size of the molecule. Molecule also. Size of the molecule is also important when you talk about ion dipole interaction. Now, as I say that ion and dipole interaction, it occurs between ion and polar solvent. For example, ion, if I take sodium ion and it interacts with water molecule H2, which is a polar solvent. Ion and polar molecule interaction. It means that is the hydration of sodium ions. Is if sodium chloride is dissolved in water, how do this sodium ions they get hydrated? This can be explained like this. So here we can add one more slide. Wait a minute. So hydration of this sodium ion, that is ion and the polar solvent. Remember, ion dipole means there should be an ion, might be positive or negative ion, and it is interacting with polar solvent. So this way, this ion gets hydrated. This is the water molecule surrounded. This sodium ion, each sodium ion it will be surrounded by 6 water molecules like this, and maybe more also. Okay. This way. So this is positive. So obviously this oxygen will carry negative charge on them, each one of them, and that is why it is polar in nature. So this hydrogen will have partial positive charges on them, each one of them. So this is nothing but the hydration of sodium ions. This way. Sodium ion gets hydrated when it comes in contact with polar solvent like water. Now these interactions are important in aqueous solution of ionic substances. This sodium ion means the possibility it is from the sodium chloride, which is an ionic compound. Ionic bond is there. So the charge density on sodium is more than anion. So in this case, charge density on sodium is more than anion. What is the anion here? That is the chloride is an anion here. So charge density is more on the cation and stronger is the ion dipole interaction. For example, if you take another example like magnesium ion, Mg2 plus. So if you compare this with sodium ion, there is only +1 charge. In case of magnesium, there is +2 charge. So the magnitude of the charge on this magnesium is more here. So it has got higher charge compared to sodium and smaller ionic radius and smaller ionic radius. Smaller ionic radius means as the atom is bigger in size, its radius will be a ionic radius rather. I'm talking about the ionic radius because the charge is more on this. So compared to sodium ion, the ionic radius of magnesium is smaller one. Okay. So in case of sodium ion, the ionic radius is 98 picometer. In case of magnesium ion, the ionic radius is 78 picometer. So it is a stronger or higher charge and the smaller ionic radius. Okay. So what is the effect of this? So hence the magnesium ion is more strongly hydrated. So magnesium ion are more strongly hydrated with water molecule than sodium ions, and they exist or they show and exist strong ion dipole interaction. As the charge on the cation it goes on increasing, the ion dipole interaction will also go on increasing. It means that. So I try to explain it. I try to explain it with taking two cations like sodium and magnesium. Now the remaining intermolecular forces like induced dipole interaction, hydrogen bonding, and van der Waals forces or London dispersion forces, we will see in the next lecture.